See, in the last video, we were discussing about resolution of vectors. Resolution is the splitting up of a single vector into two mutually perpendicular components. It is the reverse process of addition of vectors we discussed. In this video, I am going to discuss how we can represent a vector in terms of unit vectors I, j and k. So what we are going to discuss is how we can represent a vector in terms of unit vectors I, j and k. What are unit vectors? Unit vectors are vectors whose magnitude is unity. What are I, j and k? Unit vector along x-axis, we call it as I cap. Unit vector along y-axis, we call it as j cap. And unit vector along z-axis, we call it as k cap. We already discussed. Alright. Now, see what is the magnitude of I? 1. Direction along x-axis. See, the point is, when I am telling force a 5 Newton along x-axis, we understood it is the magnitude is 5 Newton and the direction is along x-axis. You might have seen sometimes in the question they will tell a vector f is equal to 2i plus 3j plus 4k. I, j, k are unit vectors. You can watch the previous videos as well. But I, j and k are unit vectors along x, y and z axis respectively. See, in this video what I am going to discuss is how we are getting this vector in terms of this I, j and k. That is one point. And if I am writing vector f is equal to 2i plus 3j plus 4k, what is the magnitude of vector f? What will be the magnitude of vector f? Modulus. These 2 points I am going to discuss. To understand this, I am coming back to parallelogram law of addition of vectors. We already discussed vectors can be in order or it can be in reverse order. If the vectors are this, we discussed it multiple times. If the vectors are in order, we will use triangular law. If the vectors are in reverse order or they are not in order, we will use parallelogram law. So what is parallelogram law? Parallelogram law of addition of vectors means if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram taken in reverse order. Reverse order means if two vectors, one is in clockwise direction and another is in anti-clockwise direction. For example, these two vectors are in reverse order. This is vector A and this is vector B. Vector A is in anti-clockwise direction, vector B is in clockwise direction. So they are in reverse order. At that time, I will go for parallelogram law. If two vectors are in same order, that means this is anti-clockwise, this is also anti-clockwise. Another case, this is clockwise, another is also clockwise. Then we can use triangular law. We discussed many times. Now here, if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram taken in reverse order, then the sum is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. That means here you will complete a parallelogram and you will get this diagonal. This is the sum. Sum of the vectors, we call it as the resultant. The sum is denoted by the resultant vector. Understood? So this portions we already discussed. That's why I am going a little bit fast. Now this is vector R. See, let us assume that this is y-axis and this is x-axis and this is the origin, and this point I am taking it as this is y-axis, this is x-axis, this is origin, and this point I am taking it as P, this is Q, and this is R. You understood? X-axis, y-axis, this is origin, vector A is OP, vector B is OR, the sum is OQ. Sorry. The coordinate of Q, I am taking it as x comma y. The coordinate of Q is x comma y. If the coordinate of Q is x comma y, what will be this magnitude? This will be x. Alright? You can easily understand. This Q is xy means you can draw a perpendicular like this, right? So that one will meet here, and this distance will be x. This distance will be x. You can understand. And what is if the coordinate is y coordinate means this distance will be, you can take it as y. This is y. OR is equal to y. So what you understood here is one second. This one OP is equal to x and OR is equal to y. Understood? Correct? From parallelogram law, what is from parallelogram law we are getting it? Vector OQ is equal to vector OP plus vector OR. Then vector OQ, this is parallelogram law. See, resultant is equal to sum of these two vectors. That means the diagonal. So vector OQ is equal to vector OP is equal to x. Magnitude is x. To convert it into vector along x-axis, we will multiply with xi. Is it right? Xi. To convert OR along y-axis, so we need to get the direction of y-axis. So we will get j. So if this coordinate is xyz, we can write it as xi plus yj plus zk. So this is the representation of any vector in terms of ijk. Understood? So from here, parallelogram law, see the coordinate of q we have taken as xy. You can take it as xyz as well. Therefore, to start with, you can take it as xy. Then OP will be x, OR will be y. Then from parallelogram law, you can substitute this, xi plus yj. If the coordinate, if you are considering z coordinate as well, you can write it as plus zk. Clear? Now, next point I am going to tell you is, see, we understood OQ, we have written vector, generally vector A is equal to xi plus yj plus zk. So the figure will be like this. So this is origin, this is the point A, this vector OA, we are taking it as vector OA, This is x, y, z. The coordinate of A is x, y, z. Then OA is xi plus yj plus zk. Now I am going to tell an important point, very important point. What will be the modulus of vector OA? The modulus of vector OA is very important. You need to understand this equation: x square plus y square plus z square. This is the modulus of the vector OA, x square plus y square plus z square. I will give you a simple question. It's a very simple question. For your understanding, you won't be getting it in your exam and all, but to understand this concept more clearly, for example, vector f, it is 2i plus 3j plus 4k. Then they are asking what is modulus of vector f. Then modulus of vector f will be root of, the formula is root of x square plus y square plus z square. That means root of 2 square plus 3 square plus 4 square. That means root of 4 plus 9 plus 16. That means root of 29. So this is the way you can calculate the modulus of a vector which is expressed in terms of I, j and k. To summarize, so what is the summary of this video? See, a vector can be represented in terms of I, j and k. Generally, vector f, for example, I can tell it as xi plus yj plus zk. See how you are getting it. It is from the parallelogram law only. That's what I explained here. So, but you need to understand any vector can be represented in terms of unit vectors I, j and k. Now, if a vector is expressed in terms of I, j, k, for example, vector f is equal to xi plus yj plus zk, then what is the magnitude? What is the modulus of that vector? That is root of x square plus y square plus z square. That is the second point. Understood? So that's all in this video. Yeah, thanks for watching.